I just wanted to talk briefly about assignment 1 since we didn't get to spend very much class time discussing the problems. Okay, so I'll just set these up and you can take it from there. Once they're set up, it's not hard at all. So a rental company charges some dollar amount per day. So let's let X represent the number of days. And they charge 25 cents a mile for renting a truck. So we'll let M be number of miles. And the guy rents the truck for 3 days. His bill is $3.44. How many miles did he drive? Okay, well, he rents it some number of days times $80 a day plus some number of miles times 25 cents per mile. And this should equal to the total charge. I guess it was sort of trivial for me to let X be the number of days because we're told that it's just 3 days. So since the bill comes out to $3.44, then 3 times 80 plus M over 4 is $3.44. And you should be able to take it from there. We did number 2 in class. It's a problem similar to what is on the written assignment and the upcoming quiz 1. A pasture is twice as long as it is wide. Draw a picture. Here is my pasture. And this here's the width. And the length is twice as long as the width. And the area, being length times width, we are told is 135,200. So then W squared should equal 135,200 over 2, and you will see that that number is a perfect square. Okay, and we talked about number 4 in class. Okay, here's a quintessential math problem. It's something that people would always make a joke about. You have 2 cyclists and they are riding towards each other, and they're 117 miles apart. So this distance is 117, and one cycle is twice as fast as the other, and they meet up 3 hours later. Okay, so distance equals rate times time, and we can call this here, the distance 1 for cyclist 1, and this will be distance 2 for cyclist 2, and the rates are what I am trying to figure out. And they both rode at, or they both rode for 3 hours. So D1 over 3 is R1, and D2 over 3 is R2. And we know one more fact we know that one of them is twice as fast as the other one. So just say that R1 is twice the rate of R2. Okay, then we can say that we can replace that R1 right there with 2 R2. So we would have that D1 over 3 is equal to 2 R2. And we still have this equation that D2 over 3 is equal to R2. So actually what I will, so this is actually messy. Let me do it. Let me start over here. So I have a better way to write it that's neater. So distance equals rate times time. Then the first cyclist's rate times the 3 hours, that is the distance ridden. And the second cyclist's rate times the 3 hours, that is the distance that the second cyclist rode. And the sum of these two distances, R1 plus, 3 times R1 plus 3 times R2, this is D1 plus D2. It must be the 117 miles. And then we also know that R1 has got to be 2 times R2. So just make the substitution right there, and we'll get that 2 R2 times 3 plus R2 times 3 equals 117. So this is 6 R2 plus 3 R2. Well, you can take it from here, right? You get 9 R2 is 117. And now you can solve for R2. And once you get that number, you can backtrack up here and plug it in and solve for R1. All right, so this will be a common problem that you see in calculus. We have a light post, or not a common problem, but a favorite problem. We have a light post. Here's the light, and this is a light ray, and there is a dude standing here, and it tells us that this light source is 4 meters above the ground, and the man's height is 2 meters. Okay. We know that he is 11 meters from the lamppost. And they want us to know, or they want us to determine, what is the length of the shadow cast. And they give you a hint to use similar triangles. So the outer triangle is similar to the inner triangle because they have this same angle. So 4 over 11 plus x is similar to 2 over x. Well then 4x is equal to 22 plus 2x, and you can take it from there. Here we have 2 fishing boats departing from a harbor. One's going east and the other one is going south. And the eastbound boat travels 3 miles per hour faster than the southbound boat. So these are their rates, and since I know the time, then distance equals rate times time. So these quantities, this is the distance traveled by the southbound boat, and this is the distance traveled by the eastbound boat. And we are told that when they, after going for 3 hours, they are 45 miles apart. So then, by Pythagorean theorem, 3r squared plus 3r plus 9 quantity squared must be equal to 45 squared. And you just solve it from there. A box with a square base. So here's my piece of cardboard, and we're going to make a box by cutting 4-inch squares out of the corners. These are all squares, and they want us to determine the size of this sheet before it is folded up, if the box was supposed to hold 256 cubic inches. So then we'll call, we can just say, let's do this, let's say that this is just our length. Then length times width times height is the volume. But the width is the length, and the height is 4. And so L squared must be 64. And then you get that L is 8. But they want to know what this distance here is. So you would have this piece right here, which is 8, but then you have to add another 4 and another 4. And that's why I got 16. Finally, we have grain falling from a chute onto the ground. So it forms a cone of some height and some radius, and we are told that the diameter is always 3 times the height. This property of a pile is called it forms something called the angle of repose, which would be expressed either as an angle, but this, it turns out, will uniquely describe an angle. And we're told, or we're asked to find the height when it contains this much cubic volume. So volume of a cone is 1/3 pi r squared h, and it's supposed to equal 1070. And according to this, you have that r is just 3/2 h. So then here you would have pi over 3, and then 3/2 times 3/2 times h squared times h is equal to 1070, and this 3 and this 3 will cancel. So it says 3 pi over 4 h cubed equals 1070. So then h cubed is equal to 1070 times the reciprocal of 3 pi over 4. Now you take cube roots and make sure that you round it correctly. And that's it.